use headphones for best experience. Thanks for your fantastic support. Hi, welcome to another video. First, let me show you that you can find a lot of my content. You can listen to it audio only on Spotify or other music streaming platforms. If you type in ASMRctica, ASMR, you will find a lot of albums here. So check it out. Also, I would like to thank you for watching my videos during the last 6 months or so when I haven't been able to record or upload so much. But it has really helped me to see that you still watch my videos and like my videos. So thank you so much for your support. Today I would like to draw an asteroid. The asteroid named 21 Lutetia. 21 means that it was the 21st first discovered asteroid. It was discovered in 1852. focus a little bit more on the impact craters. I think it looks a lot like a skull, actually, with the eyes here, the sockets for the eyes here, the nose, and the upper teeth here. And the cheekbone, and this cheekbone here is a bit deformed. Or maybe an alien skull. The craters on Lutetia are quite smooth, so it's not super easy to find a way to draw them. It's more like shading. Yeah, this asteroid is actually known for being have a quite smooth surface, and especially in this region here, in the middle of this image, it's actually the North Pole, right here, and it's one of the youngest regions on Lutetia. And that's probably why it's so smooth, it looks so smooth here, the surface, because it's like covered in a smooth ejecta blanket, 600 meters thick approximately. And this partially buried the older craters from this area. crater here, almost heart-shaped. It reminds me of the surface of Pluto, actually. It's called the Danuvius labes. So there are several craters here, hidden underneath. And another reason probably for Lutetia looking this smooth is because it's believed to be covered in a very thick layer of regolith, up to 3 kilometers thick layer. This very fine dust that also covers the moon and Mars, I guess. And this is like the temple on the skull, this region, or this flat crater here. The maxilla and the mandible is missing here. This is a quite prominent crater, at least from this angle here. It's called the Basilia Crater, I think. And these two very flat craters, just small depressions here, I think maybe they are this smooth because you have this Danuvius labes on top of it. The much younger crater here. But you can still see some shadow here and here. They're called the Toletum and the Gerunda. And this is a prominent one of the nostrils. It's called the Bonna crater. There's a lot of shadow here on this side. It's because the entire right part here of this image is a very large crater, the Basilia Crater. I like that the name also resembles maxilla. It's Basilia Crater. Basically, the entire eastern part. I don't know if it's east, but this is the North Pole. So this region is called Ticinum dorsum. And here's the Sequana fossa. Fossa is a long, narrow depression or trench. Turicum, this quite large impact crater. And this smooth crater is called Lugdunum. And this ridge here is called Tiberis Rimae. It's like an escarpment here. I thought it was part of a crater, but I'm not sure. The edge of a crater. And there are smaller craters inside this one. So this part is Achaia. The region is called Achaia, and it's one of the oldest regions on Lutetia. The other older region is Noricum. Noricum is here, so they are heavily cratered. Evidence of a lot of impacts during all these 4 billion years since the formation of the solar system, when Lutetia was formed together with other planetesimals that and some of them became planets eventually, but not Lutetia. It stayed as an asteroid, but it's a very strong asteroid. It's not like the rubble piles that you see quite often in the small asteroids. It's quite small, but definitely not one of the smallest. It's 100 kilometers in diameter, approximately. So that would be approximately 60 miles. And it's an M-type asteroid, so it's very high density, very dense. And first, it was believed that it was nearly purely metallic, like a planet core. For example, the core of the Earth, That would be just maybe iron and nickel, I guess. Two most common metals in cores and in M-type asteroids. But later it was discovered that probably it's more like metal-rich silicates and not pure metal, and more like resembling the chondrite meteor or meteorites. And then it would also contain some hydrated minerals and more resemble the C-type asteroids. The most common type of asteroids, but the C-type asteroids, the one that contains water quite often and organic material, they are most often found in the outer part of the main belt. If Earth is here, Mars is here, main asteroid belt is here, then we have the inner main belt starting at approximately 2.2 astronomical units from the Sun, and then we have the outer part of the main asteroid belt at approximately 3.2 astronomical units from the Sun. Sun to Earth is 1 astronomical unit. That's how this distance is defined. Sun to Mars is 1.5 astronomical units. Sun to Jupiter is 5 astronomical units. And to the main asteroid belt, it's between 2.2 to 3.2. So the width of the main asteroid belt is 1 astronomical unit approximately. So it's quite extensive. If you also think that it orbits the Sun, quite a very wide disk of remnants from the formation of the solar system. But yeah, my point was that this asteroid's orbit around the Sun is at 2.4 astronomical unit. So it's part of the inner part of the main asteroid belt, where you more likely find the S-type asteroids, the stony asteroids, and not the C-types. But it's just, I mean, they are distributed all over the area, so it's just that they are more common. The C-types are more common in the outer and the S-types in the inner. But this is M-type, that is a bit different from both S-type and C-type. But yeah, recent discoveries shows that it maybe more resembles a C-type, those that are common in the outer part of the main belt. a lot of craters also in this ancient region, the Norco. And here it looks a bit fun or strange on the image that I've seen. But it looks like it's a sharp point here, but I don't think that's the case. It's just the light. So here's the dark side of the asteroid that starts here. Because Lutetia has only been discovered by a flyby in 2010 by Rosetta probe. Rosetta from ESA. It passed in July 2010, and so only half of the area, the surface, is observed. So the dark side is still hidden in mystery, and it's like starts here, so you can only see. Yeah, it kind of. I guess it's a smooth continuation here, but it's completely dark here. And it's believed that on the other side, the southern side of the asteroid Lutetia, there's a huge crater. I don't know how they came up with this, but it has maybe to do with the spectrum analysis. And that crater is named the Suspicious crater because it's just suspected that it could be. It's no evidence at all, but yeah, somehow they come up with the theory that it might be a 45-kilometer crater on the southern side. So if it's 100 kilometer wide, it would be like this big. So I guess it's a lot of shadows that makes the forms here on this asteroid. I've forgotten a quite prominent crater here. Here there are some rupees. Rupees here. Like those, I remember those from my video about Mars. They looked a bit like this. Some kind of an escarpment in the landscape. Lutetia has quite a lot of these landslides and grooves. Its surface that maybe indicates internal fractures. So it's definitely not a rubble pile held together by gravity. It's really dense. When I showed this to my sister, she saw a completely different face than I saw. I saw this skull here, with the teeth, the nose, and the eye sockets, and the temple. But she saw actually a profile side view face of a lady from maybe the 1800s with a nose tip here, the eye here I think, and then a hairstyle that made her think of this 1800s lady, I guess, and then the neck and the face, or like the mouth or cheek. So now I can clearly see that face here also. Also, I remember I could see a horse, but that was when it was flipped on the other side somehow. I think here was the nose of the horse. That was actually the first face I saw. Like here, and or maybe like a cartoon version of a horse. This would be the eye, but upside down, and then like the nose, mouth, the cheek, and the ear, and the neck. And this region is called Narbonensis, the region with the Basilia Crater, this huge crater here. And this region also has a lot of pit chains and grooves formed later than this big crater. And it's also a crater here on the side called Salomacus. And this crater here that you only can see half of, then it's hidden in the dark, the other side of it. It's called Florentia. And this region, very bright because of the sunlight here, is called Rhaetia. And Pannonia is another region here on the other side. And those are also thought to be huge impact craters. Then it's Etruria, a region approximately here. And it's divided into region because they have the same type of geology and surface. So these are very smooth areas. Etruria with an area called Roma Rhenus and Rhenus rupes. These, I guess, are the Rhenus rupes, and these are Tiberis Rime. But Baetica, this region here, that contains the Danuvius Labes, is the youngest, as I'd said before. So 7 regions are found on this side, this lit up side of Lutetia: Baetica, Achaia, Noricum, Narbonensis, Etruria, Rhaetia, and what's the last one? Which one haven't I said yet? Pannonia, yes, this one. So that's the 7 regions. before I finish this drawing, I would like this face that I'm always talking about to be quite prominent. I don't know why, but then this crater is important, the left nostril. And the second eye. I would like to draw more of these asteroids. It's so fun. They're so much more fun than planets because it's happening so much on the surface. So maybe that could be an idea for future videos. And if you have a request of your favorite asteroid or astronomical object, it could of course also be a round object. Please let me know in the comments. It would be super fun to know. I haven't really drawn. Yeah, I have made a Mercury drawing map before, and then a Mars ramble video where I showed you the Mars globe. And some star constellation videos, I guess, long time ago. But I would like to do more astronomical videos, astronomy videos in the future, since I've read so much about it lately. I don't really get a feeling for how this region, I mean the three-dimensionality of this region, because it's like cut by the sunlight here, so you don't see what's happening here at all. So here it's just dark, but the planet's still, the body continues here in some mysterious way. Did I mention the name of this crater? I don't remember. It's called Burdigala. Quite prominent. And Nisaya, this one. I would like to show you some, or I would like to talk a bit about the size of astronomical objects, how you can compare, think about it. If you wonder how big is this compared to other bodies. And I like to think in that way, also when it comes to distance from the Earth, from the Sun, from other objects, and also size. And first of all, it would be nice to think about the entire asteroid belt, the main belt. A long time ago, it was believed that the belt was remnants from a planet that got destroyed. So it had been a fifth planet, or the fifth inner planet. But then, now it's not believed that that's the case anymore, because if you take all the material in the asteroid belts and put it together and try to make a planet of it, it's still very small. For example, the largest asteroid is Ceres. Here is Ceres. It's the only asteroid that is round, spherical in shape, and it is spherical because it's so large, so it has so much gravity that holds it together, and kind of, I think it's differentiated also. It has started this planet differentiation with a core and a mantle and a crust. So when it gets large enough and dense enough, it can start to act like a proper planet. And Ceres is the only object in this part that is like a small planet. So it's actually defined as a dwarf planet since 2006, together with Pluto and a lot of other objects. So it's not just an asteroid, it's also a dwarf planet. And Ceres is 940 kilometers in diameter. And how much is that? Well, if you put 3.6 Ceres in a row, put together like this, then you get the diameter of the moon, the Earth's moon. Because the moon has a diameter of 3 something. What is it? I tried to memorize these numbers a couple of days ago, because I thought it would be nice to know. I guess, was it 3,400 something? And if you take the moon 3.5 times, or 3.6 times actually, then you get the diameter of the Earth. So I thought that was a quite interesting coincidence, that the ratio and relation between Ceres and the moon is the same as the moon to Earth. So if the moon would be Earth, then Ceres would be the size of the moon, our moon. And Earth diameter is 12,756 kilometers, I think. And the Sun, for example, is more than 100 Earths. I think maybe 109 Earths. .4 million kilometers. And the distance from Earth to the Moon is approximately 30 Earths, or 384,000 kilometers. And the distance from the Sun to Earth is 1 astronomical unit, which is, I think, 150 million kilometers. And that would be almost the same number of suns put in a row as the number of Earths put in a row that will make the size of the Sun. So 109 or 107, I think, Sun diameters is 150 million kilometers, because one Sun diameter is 1.4 million kilometers. But yeah, one thing that I found really interesting was that if you would make some kind of super series and to take all material from the asteroid belt and put it in one planet, because that's how you were thinking about the asteroid belt in the past, that it had belonged to one planet, then it would be like putting 3 planet series together. Not the diameter, but the mass. So the total mass of the entire asteroid main belt is 3 times the mass of Ceres. And then actually you would only take the radii, or the diameter, times 1.44. So 940 kilometers times 1.44. And that's 1,354 kilometers. And that would be the diameter of astronomical object that would include all the asteroid belt. So this is not super big planet, but actually it's not bigger than Pluto, because Pluto, even though Pluto is not a planet, but Pluto is also, just like Ceres, a dwarf planet. It's round, spherical, and it's 2,120, no, it's 2,000, I don't remember now, is it 375 perhaps? 2,375 kilometers, and Pluto's moon, Charon, is 1,212 kilometers in diameter. It's a very large moon compared to its the body it's orbiting. So actually, it's not clear that that's actually the case, that Charon is orbiting Pluto just like a regular moon, because it's more like it's a binary system. They have such gravitational effect on each other, so this could more be seen as the only binary dwarf planet system in the solar system discovered so far, I guess. Because it's half the size. The diameter of Charon is half the size of the diameter of Pluto. So then you can see that the super series, the hypothetical super series that I'm trying to create here, with the entire asteroid belt, would be just a little more than Charon in diameter. So it would still be a dwarf planet. Mars is also quite small because it's the next planet. Jupiter has such strong effect on all the objects on where the asteroid belt is. And that's probably why no planet had been able to form in this region, because even though it's still 2 astronomical units from Jupiter, it still has such huge effect on it. So maybe it has disrupted all the planetesimals so much in this area, and like have them flying away in all directions. So it just couldn't form anything here. The closest planet that could form is Mars, of course, which is at 1.5 astronomical units from the Sun and 3.5 astronomical units from Jupiter. And Mars diameter. It would be nice to remember Mars diameter also. I think it's something with 6. 6, 7, 8, I think. That's easy to remember. 6780 kilometers. So it's basically half the diameter of Earth. So then it's considered a planet. Because it also has cleared most of its orbit from asteroids, even though there are asteroids there as well. Mars crossing asteroids. Also Earth has there are small asteroids around Earth's orbit also. So even though Earth and Mars is considered planets, they haven't completely cleared their orbits, which is one of the criteria for being called a planet. But I was thinking, to memorize some of these numbers, I was thinking Earth is 12.756. That's something I just have to remember, but it's nice that it's both 5, 6, and 7 in the decimals. And then Moon is 3. 75, I think. See, or I have to check. No, I forgot the number here. So 3.475. Then you have the Moon, and Pluto is 2.375. Yeah, it was here I found some pattern. Here is 12 and 75. No, here is how I thought about it. Now I remember. 1, 2, 75, and also 6. And here is 3, 4, and 75. And here's 2, 3, and 75. So you have 1, 2, 2, 3, and 3, 4. And the Charon is 1, 2, 1, 2. Also easy to remember. I think that's it for today. Thank you so much for watching this video. It has been really fun to record this one. And I'm happy to be able to record again. And I'm looking forward to edit this video and publish it very soon. So yeah, if you have a request of other asteroids or other astronomical objects, please let me know in the comments. Thank you so much for watching. Sleep.